This is part two of solving systems by elimination. And if you did yesterday's assignment, I'm hoping that you noticed most of them were pretty easy. I mean, the answer basically just dropped out. But as I said yesterday as we were explaining this, I'm hoping you paid attention to why one of the variables got eliminated. Notice on this one, the y went away because this was a positive 1y and this was a negative 1y. On this one, the x went away when we added these together because this was a negative 3x and that's a positive 3x. And then of course that story problem we did, the y is going to go away because again this is a positive 1y and that's a negative 1y. So on today's assignment, it's going to be a little bit different. So I'm going to show you two examples here of what you're going to encounter today. And this is much more typical of the type of systems of equations that you're going to be solving long term and that you need to be really good at because unlike the ones from yesterday, normally they're not set up for elimination. It doesn't just drop out like that. So what I'd like you to show you is this. This one says 3x plus 2y equals negative 8 and 4x minus 5y equals negative 26. Neither one of those is set up for substitution, so we certainly wouldn't want to do that, and we probably wouldn't want to graph these either because that's a bit of a pain. Notice that this is a 3x and a 4x. They're both positive, so if we were to just add those equations together, they're not going to get rid of the variable. This is a positive 2y, this is a negative 2y, so if we added those together, they'd cancel a little bit, but not completely. We'd end up with a negative 3y. So here's what we do. If this is equation number 1 and this is equation number 2, what we're going to do is we're going to make it so one of those would get eliminated. So one of those variables will be eliminated. Now here's what we're going to do. We're going to make these the same number and the opposite sign. So I could make these 12s. That would be the smallest number that we could make them. Or over here I've got a 2 and a 5 and I could make both of those into, smallest thing I could make those into would be a 10. So we're going to multiply this equation and this equation by different numbers, and we want them to have the same coefficients but different signs. But I would rather take advantage of this right here, the fact that this one's already positive and this one's already negative. We've got part of that elimination technique already taken care of. So here's what we're going to do. I'm going to take this equation and I'm going to multiply it by 5. So I'm going to put that 1 out in front here and the 2 here. I'm going to put a 5 right here. Now what that's going to do is that's going to make this a 15x, that's going to make this a plus 10y, and that's going to make this a negative 40. So what I've done is I've basically just distributed through here. I've multiplied both sides of the equation by 5, and I end up with 15x plus 10y minus 40. Now let's think about what I'd need to multiply this one by. I really want that y's to go away. I want to take away the 10y, and I've already got the negative. I want to take advantage of the fact that this is already positive. So I need to make that a negative 10. Well, it's already a negative 5, so if you think about it, if I just multiply everything by 2 and distribute through like this, that's going to make this an 8x, that's going to make this a negative 10y, and that's going to make this a negative 52. Now, I've got equation number 1 and equation number 2. I'm going to call this equation 3 and equation 4. If this was a true equation, that's got to be a true equation because I did the same thing to both sides. If this one was a true equation, multiplying both sides by 2 is going to make another true equation. So I actually have 4 true equations. Equation 3 and 4 are copies or adjustments on equation number 1 and number 2. But equation number 3 and 4 have an advantage. If I just put those together, they're going to be eliminating the y. So what we get here is we get 23x, we get no y's, and then over on this side we end up with a negative 92. Finish solving this by dividing by 23, and if you want to grab a calculator, be my guest, that actually goes in there negative 4 times. Okay, so we've got the x value. Now we have to figure out what the y value, and now here's where it gets kind of interesting. Unlike some of the other ones that were relatively simple equations, or we did them by substitution or something like that, it took a bit of work to get to this part of the answer, to get the first half. It's still going to take a little more work to get the other part of the answer, to figure out what y is equal to. We could plug into equation number 3 or 4, but look how big those numbers are. That's usually going to happen. These are going to have bigger numbers than the original one. If I look at the original equations, do I want to do a 4, a negative 5, and a negative 26, or a 3, a 2, and a negative 8? I'm going to take this and I'm going to plug it in right there. So this is going to be 3 times negative 4 for whatever x is, 2 times y, and then on the other side it's negative 8. So this is a negative 12 plus 2y equals negative 8. We're going to add 12 to both sides, so this would be 2y equals, let's see what we get here, we get a 4, and then we're going to divide both sides by 2, so we get y equals 2. So that right there is what y is. Now this isn't a story problem, so we're going to go ahead and write this as an ordered pair. So this is going to be -4 comma 2, and again what that means is if we were to graph these, that would be the point where the lines cross. They would cross at back 4 and up 2. That would be the point where they cross. Okay. Let's take a look at another one. I'm going to go ahead and draw a big wall here, and these do take a little bit more time, so please be careful with these. I'm going to show you these two examples and then turn you loose on the assignment. Let's take a look at this right here. We've got a -3 and we've got a 5, so they're both coefficients for x. We need those to be the same number but opposite sign. So they're already opposite sign. If we were to make them the same number, the smallest number we could probably do would be 15. We could turn them both into 30s or 60s or things like that, but let's pick the smallest number. Least common multiple is what we say. So that's a possibility. And then we've got a +8y and a -5y. They have different signs, so that's good. And then on this one right here, 8 and 5, we need to turn those into the same numbers. So we could do 8 and 16 and 24 and 32 and 40. Those are the multiples of 8. That's the first one that 5 would go into. So we can either make these 15s or we could make those 40s. I don't know about you, but I think the 15 would be better. So here's what we're going to do. This is equation number 1. We're going to multiply this by something that would make that a 15. So we're going to multiply that by 5. So this is going to be -15x. Distributing through here, this is going to be +24y, oops, sorry, +40y. 40y, there we go. And multiplying over here, that's -15. Always makes me a little nervous if I make a mistake. So -15, +40, and -15. Okay, I'm okay with that. And then on this one right here, we want to go through and we want to turn this one into a 15. We want to turn that into a 15. So we're going to multiply by 3. So again, we'll distribute through with each one of these. That's going to be a 15x. Good news there. That's looking good. This is going to be a -15y. Yeah. And then this over here, we're going to end up with a 90. 3 times 30 is 90. Okay, so let's take a look at what we've got. Let's see. These go away, so we're left with a positive 25y, and then over on this side we have, let's see what we've got, that would be a 75. So we're going to divide by 25, so we're going to get y equals 3. So there's the first part of the answer. We know what y is. Now we probably don't want to plug into either one of these equations because the numbers are so big. So let's come back over here, and again I'm going to change colors so we can keep this straight. Which one do we want to plug into? Let's plug into the one that has fairly small numbers. This has 2 negatives, this one only has 1. So I think I'll plug into that one. Again, it doesn't matter as long as you're careful. So we get 5x minus 5 times y. Y happens to be 3 in this case, so we'll put a 3 right there. And then on the other side is a 30, so this is going to be 5x minus 15 equals 30. We're going to add 15, so we're going to get 5x equals 45. We're going to divide both sides by 5, and we get x equals 9. So I'll put a dotted circle around that one right there, and that is the answer. We write it down as an ordered pair because that's the point where the lines cross. We circle that and we are all set to go.